Hi friends, welcome back. Today we are going to solve Codeforces problem. They are everywhere. Before we start looking into the problem statement, the some examples and the Java solution for this problem, I want to mention that my channel is dedicated to help people who are preparing for their Java J2 interviews and for their coding interviews. You will find a lot of helpful videos on this channel that can help you in your Java interview preparation and in your coding interview preparation. You will find over 250 solved different varieties of coding problems which were previously asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big tech companies. And those are selective problems to cover important coding question varieties such as BFS, DFS, matrix problems, graph problems, binary search tree problems, dynamic programming problems, as well as coding interview questions related to linked list strings, optimization problems using priority queues, and a lot of other logical questions. So this channel can definitely be helpful in your job interview preparation. So please subscribe to this channel now. So let's look into the they are everywhere problem statement first, and then we will understand how we can solve this problem with example. Sergei B, the youth coach of Pokemons, has found the big house which consists of n flats ordered in row from left to right. It is possible to enter each flat from the street. It is possible to go out from each flat. Also, each flat is connected with the flat to its left and flat to its right. Flat number 1 is only connected with flat number 2, and flat number n is only connected to flat number n minus 1. So it is like there are a lot of flats in a row, and you can go from each flat to the neighboring flats, right? And that's what it is saying basically. There is exactly one Pokemon of some type in each of these flats. Sergey B asks residents of the house to let him enter their flats in order to catch Pokemons. After consulting, the residents of the house decided to let Sergey B enter one flat from the street, visit several flats, and then go out of some flat. But they won't let him visit the same flat more than once. Sergey B was very pleased, and now he wants to visit as few flats as possible in order to collect Pokemons of all types that appear in this house. Your task is to help him and determine this minimum number of flats he has to visit. So in the first, like, let's go through what input is given to us. So n is given, which is number of flats in the house. So for example, here 3 flats are there in the house, right, in the row basically. In second line contains the row S with length n. It consists of uppercase and lowercase letters of English alphabet. The ith letter equals type of Pokemon which is in the flat number I. So this is the string basically that is given to us, and every letter is a type of Pokemon. So for example, there are 2 capital A types Pokemon here and 1 small A type Pokemon here, right? So print minimum number of flats which Sergey B should visit in order to catch Pokemons of all types which there are in the house. So for example, if you look at this first example, right, let me just make it big. So there are 2 types of Pokemons Sergey has to catch, right? One is capital A and one is small a. There are 2 types of Pokemons, right? So either he can catch these 2 like this, so length is 2, or he can catch these 2 like this and length is 2, right? So we have to output 2 here. Now let's look into this another problem. So let's just copy this problem. We'll go into whiteboard so I can show it like a little bit better here. So let's just make it big. So this is the string basically, and what we have to do is we have to find out what basically this is a string problem, right? And we have to find out a substring with all different characters that are present in the string, right? So in this string, if you can see the number of characters that are present in this string, or let's just enumerate what characters are there, right? B is there, C is there, A is there, capital A, right? So there are 3 types of characters in this string. So we have to find out minimum length substring that has all of these three characters present. So as you can see, this is one string where all the three characters are present, right? BCA. This is one string, or you can take this string, right? This string basically ACB. This also has all the three characters present basically, right? So this is also length 3 and this is also length 3. So we have to output length 3 basically, right? Minimum length is 3. So as you can see, 3 is the answer for this question. Now let's take this last example on a whiteboard where we will formulate our solution. So this is 6 length string. So first thing is what we will do to solve this problem is we will put all this character into a tree set, right? Java has a tree set which can hold like unique characters, right? Because it's a set and they will be ordered. So as you can see, B, C, A and E. So these are the 4 characters in this string, right? So we have to find out minimum length string which has all these characters present, right? So if you just visually look at the string, then the minimum length string which has all these 4 characters present is this string, right? That I am highlighting. This is the string which has all the 4 characters present, A, B, C and E, right? This is the smallest string and its length is 5, right? As you can count it, 1 2 3 4 5 characters length. So here the 5 is the answer, right? So so this is the way we can visually look at this string, and we found a substring which is the smallest, right? So let's develop an algorithm to solve this problem. So what we can do is first we will create the tree set by adding all this. We will loop through all these characters. We will add it into tree set. So we will get B, C, A and E. So we will know that the size of this tree set is 4, right? It has 4 characters in it. So after that we will take 2 pointers. So left pointer will point here, right, to this first A, and right pointer will go like it will also point here first, and it will keep going, like it will go like A, then B, then C, then this C, then E. So right pointer will move basically, right, as I shown you. And as we move along, then we will keep forming a hash map of frequency of these characters, right? So frequency hash map we will form. So let's just look into this. Like let's say this is our hash map, right? This is our hash map and it has a frequency. So once it visits this first A, then it will keep the frequency as 1, right? Then it will again second A, then it will update the frequency from 1 to 2, right? And at the same time we will keep checking the size of the hash map. If the size of the hash map is equal to tree set, then we will have to do some logic in that case, right? So right now our hash map is not equal to tree set, right? This is our hash map, right, which is basically frequency map. So now A is 2. Now we are at B basically, right? Right is at B. So when it is at B, we will update the frequency of B to 1, right? Then we will go to C. Then we will update the C to 1. Then again there is second C here. So second C means we will update the frequency of C to 2. Then we will, the right will go here at the end. It is pointing to E. So E will have frequency 1, right? So at this time when we enter the E frequency 1, the size of the hash map becomes equal to tree set. Now the size of the hash map also becomes 4, right? And it is also equal to tree set. Tree set also has a size 4. So in this case what we will do is we will calculate the length of the string basically. So length of the string means that, so left is still pointing to this A, right? Left is still pointing to this A, and this is where the right is pointing. This is now our right basically, right? So we will calculate this total string length, right? 1 2 3 4 5 6. So let's say we have a variable called as answer, right? So we will calculate this length and we will update the answer to 6, right, because this length is 6. So after that what we will do is again now we will move the L left to the next pointer, right? So the L will now move to this A. This one become L, right? and at this time again we will go through our hash map. If a is present, then we will reduce its frequency. If it is more than 1, right, we will reduce its frequency. So now frequency become 1. So now it was 2, now we reduced it by 1, so it became 1, right? So again in our loop we will again check if the tree set size and hash map size is equal, right? Still our hash map has 4 elements, right? A, B, C and E. So its frequency is means its size is still 4, which is equal to 4. So in that case we will again count the length of the string, right? So string length will be like, I will just highlight this. So this is the string length, right? Again A, B, C, C, E. So now the length become 5. So we found a length which is smaller than the answer. So we will update the answer to 5, right? Because this is a smaller string that we found. Previously we found a string with length 6. Now we are finding with length 5. So we will update the answer to 5. After that again our left pointer will move to the next one. So now our left pointer will go to this B, right? So now this left is now at B. So what we will do is when we are moving the left pointer to the next position, we are actually losing this A character, right? So now there is no A in this string. Now our string becomes this one, right? B, C, C, E. So we don't have any A, so which means that we will reduce this means we will remove this A now basically, right? If in this case, because now BCCE does not have any A, so we will remove this A from the hash map basically. So hash map size will become 3. So in this case our hash tree set and hash map does not match basically, right? So we will basically like keep looping this until so we will also put one condition in the loop where in this case when now they are not getting equal basically, right? They used to be equal but now they are not equal. So in this case we will check if r is equal to length of the total string. It is 6, right? Total string length is 6. R is also pointing to the last character. In this case we will break out basically, right? We will break out of the loop and we will just return our answer 5 basically, right? So 5 we will return in that case. So this is how we are going to formulate our logic to solve the Codeforces problem. They are everywhere. So this is a string related problem. So this is the logic. So let's just take a look into the Java code now. So first we just created one tree set, right, of characters, because we are going to go character by character. N is equal to 6, which is the length of the string that is given to us, right? So first we will convert this string into a character array, and we will go through this string and we will add all the characters into the tree set, right? So our tree set will become like this, right? B, C, A, E. All the characters will be there into the tree set. After that we define the hash map of character comma integer. So I'll just write down a comment here. So this is a frequency hash map, right? Frequency hash map, right? So every character and its frequency we will keep track of that using this map. We are going to take two pointers. One is left pointer and one is right pointer. As I mentioned you here, both will be pointing to the first A in the beginning, right? First like both are pointing to 0 in the beginning, and right will keep moving on the right side, right? Then we have one answer variable. It is integer dot max value is the initialization for that variable. So while left is less than or equal to right, we have a loop, right? So first thing is we wanted to check if our map and tree set size is same, right? Then in that case we have to update the answer by using right minus left and answer, right? Whatever is the minimum we will update. So as I mentioned you here, right, whenever the 4 and 4 size becomes equal, we calculate that left right minus left, right? Right was at the E position and left was at the A position, so total becomes 6, right? So that's what we are doing here. So that same thing we are doing here, that logic. After that, if the map size is less than the tree set size, right, in that case first thing is we will check if right is equal to n, then we will just break out of this loop basically, right? So this happens when we are like as I said, when the left pointer moves to the b and right is at the 6, in this case it happens, right? It means that we already found the smallest string, so we will break out basically. So that takes care of the breaking out part, because we already, when we found a smallest possible string with all the different characters that are present in the original string, we will break out. Otherwise we will check if the map contains the right character, right? If it contains it, we will increase the frequency by 1. If it does not contain it, we will just assign the frequency to 1 in the beginning, right? And we will increment the right pointer, right? Because we are going on the right side. So this thing, so let me just remove these things, right? So we can reuse this space again, because it's a lot of clutter here. Yeah, so now basically what we are doing is, as we go here on the right side, we will keep uh, updating our map, and we will keep after that we will keep incrementing the right pointer, right? Now if the tree size, if the map size is not less than the tree size, right, we will check, which means that they both are, let's say, equal, right? If they are equal, in that case, if the map like, we will check the left character, right? If its frequency is 1, then we will just remove from the map. Otherwise we will decrement the frequency by 1, right, and increment the left pointer. So when does this condition happen? So let me just show you that. So let's just go quickly again through the same logic that I already mentioned, so you will be clear. So here a will be 2, right? Then b, then c. So like after that b will be 1 frequency, c will be 2, right? And e will be 1 basically, right? E will be 1, and the pointer, the right pointer reaches here basically, right? This is the right pointer, this is the left pointer. At this time, the when we enter e into the map, this size becomes 4, right? And so the size becomes 4, and here we will like first we will calculate the answer, right? In this case we will calculate the answer. So answer is basically right minus left, so this total string, basically this total string, right? So these are 6 characters, so answer becomes 6. So let's just calculate, the answer is 6 at this point. And after that the control will go here basically, right? The control will go here because the tree size and map size both are same. So now we will look into the position of left character, right? So left character position is basically a. So a is, we will look into the a, so its frequency is 2, so we are going to reduce its frequency to 1, and we are going to move that left pointer here. So left pointer will go here now, right? So now this left pointer will go to the next position, right? So that's what we are doing, and this same thing we are doing in the code. So here we are reducing it, the frequency, right? So again, we next time again when we are moving to b, right? Again when we are, the left is moving to the next character b, then the frequency of a will be 0. So when it becomes 0, we are actually removing it from the map, from the hash map, right? So that part we are doing here, map dot remove, right? At that time the map, and we are incrementing the left, so at that time the total size of the hash map becomes 3, right? Because it is now only b, c and e characters in the map. And in that case we will just come to this place where map size is 3, which is less than 4, and right is n, right? Right is equal to n, so we will just break out in that case, right? And we will put our answer. So answer will become 5 basically, right? When a pointer moves here, then this length we recalculate again, and we update the answer to 5, right? So this is how we are solving this problem using this logic. The code forces, they are everywhere problem, and we will print the answer at the end. So let's go ahead and execute this code snippet, make sure it works. So it's giving us answer 5. So as you can see, this is the case that we looked, answer is 5, right? So which is correct answer. Also, let's say if we update it to 8 and if we put 2 A's here, let's say we add 2 A's, still to get all the characters, still we have to take this as a substring, right? So still the answer will be 5, right? So make sure, so still our answer is 5. So this is correct. So let's take a look into this another example. So we'll just update our example to make sure that this unit test case also works. So let's go ahead and execute it. So 3 is the answer. So 3 is the answer, which is the correct answer we are getting. And let's just make sure this also works. It's always a good practice to go through all the unit test cases that they have given us to make sure those works. So 2 is the correct answer here. As you can see, 2 is the correct answer. So this is a string problem where we have to find out a substring which contains all the characters, all the different characters that the main string has, right? So that is what the problem is basically. And since it is a substring, it is obviously it is a continuous string, right? So this is how we solved it. So let's do a quick recap of how we solved it. We used a tree set to calculate the to keep track of the unique characters in the main strings, and after that we actually used a hash map, right, to hash map to keep track of the frequencies of each character, right? And then we used a left and right pointer to calculate the lengths, and whenever we find out the map becomes equal size to the tree set, then we will keep calculating the length and we will keep moving the left pointer, right? So as you can see, left pointer is keep moving and we will keep updating the frequency into the hash map. If the frequency is 0, then we will just remove it from the hash map basically, right? And at that time the frequency does not match with the tree set, then at that time we will just here, right, in this case we will just make sure that if our right pointer is reached the end of the string, we'll just break out and put the answer, keep the answer, right? So if you are new to my channel, there is a dedicated Codeforces playlist on my channel that has a lot of solved Codeforces problem explained with Java code examples and whiteboarding sessions. Go through it, it will definitely help you in getting a grasp of different varieties of problems. Also, there is a big playlist on my channel called as Leetcode and Leetcode Solutions. That playlist has lots of solved different varieties of coding questions such as BFS, DFS, matrix problems, graph problems, binary search tree problems, dynamic programming problems, as well as string and linked list related coding interview questions, optimization problems using priority queues, and a lot of different varieties of logical questions. And those problems are previously asked by Google, Facebook, Microsoft, Yahoo, Amazon, Apple, and many other big tech companies. So going through those playlists, solving those examples will definitely help you in your coding interview preparation. If you are preparing for telephonic Java interviews, there is a playlist called as Java interview on my channel that discusses frequently asked Java interview coding questions, and how to answer those questions is also discussed there. So you can look at those playlists. Apart from that, there are playlists that discusses Java architecture related videos, also Java design patterns, different Java string related interview coding questions are also there. So it will give you a good preparation. If you like this video, if you find this video helpful, and if you like the way it's been created with whiteboarding session, examples, and Java code, please give it a like. Also, if please subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Main goal of the channel is to help as many people as possible in their Java J2 interviews and in their coding interviews. They can also look into these solved coding problems and understand how to approach different varieties of coding problems using Java, and what Java APIs and libraries to be applied to solve different coding problems. If you like this video, please give it a like. If you have any questions regarding the video, please put your questions below the description section. Also share this video with your friends and colleagues, and thanks for watching this video.